Hi everyone! In the previous video, concepts like the lattice and the basis were introduced. Eventually, we will discuss the three-dimensional crystal structure. However, in this video, we will consider a little simpler example, two-dimensional graphene. Maybe many of you have already heard of the graphene. It is a single layer of carbon atoms in a two-dimensional hexagonal lattice. Can you find the lattice and the basis? For 2D lattice, we need two vectors. Let's find them. At the first glance, it is easy to say these two vectors connecting two neighboring atoms are the lattice vectors. Unfortunately, they are not. Why? If they are lattice vectors, then these 2 points, we must have the carbon atoms, but we don't have atoms at those points. Therefore, these two vectors cannot be the unit of copy and paste. Instead, we can find that the vectors connecting the second nearest neighbors are the lattice vectors. When we move along these vectors, the lattice point is always found. Of course, you can notice that there is missing atoms. For example, this atom is not located at the lattice point. Remember that the actual atom repeated in the lattice is specified by the basis. Therefore, two neighboring atoms shaded in the slide consist of the basis. When these two atoms are repeated following the lattice vectors, we can have the atomic structure of the graphene. In this last slide of the part 2, I just wanted to show you the animation. We have the basis and two lattice vectors are found. Let's repeat the basis. Next, we can go further. More lattice points are generated by adding the lattice vectors. Then, copy and paste. You can easily understand that the graphene structure can be generated in this way. Okay, in the part 3 of the lecture 1, we will study the atomic structure of silicon. Thank you.